one after the hour. We can probably kick it off. Say goodbye to the music. So hello, everybody. I know more folks are going to be straggling in here. Not struggling, slowly coming in over the next few minutes. But welcome to Simplify Host Firmware Updates with the Notecard. So over the next 45 minutes to an hour, no more than an hour, I promise, we're going to be diving into a new capability of the Blues Wireless Notecard called Notecard Outboard Firmware Update. So don't worry, we're going to unpack everything and anything, all your questions. We're going to answer all of those throughout like a technical deep dive and kind of a real world scenario that we're going to walk through as well that shows off the usage of it, along with some great new capabilities from the IoT platform and Datacake. And make sure I got this. There we go. So it just so happens that today is Groundhog Day here in the US, which is just as ridiculous as it sounds, because today we learn, whoops, wrong button there. Today we learned thanks to a groundhog named Punxsutawney Phil, whether or not spring is coming early or not. We just discussed this earlier. Turns out he did see his shadow, so that means we have 6 more weeks of winter. Whatever. Those of you familiar with the comedy Groundhog Day here with Bill Murray, I want you to know how badly I wanted to theme the entire webinar around this movie, but alas, we're playing it slightly more straight today. Anyway, as questions pop into your head, of course, during the webinar, please use that Q&A panel provided to ask your questions throughout the webinar. We're going to answer as many as we can live privately, but then we'll answer some of the best ones publicly at the very end. And speaking of questions, we always get the question. In fact, I just saw it come through. Is this being recorded? And the answer is yes, it is being recorded. And it will be available on our YouTube channel right here at youtube.com/blueswireless. While you're there, of course, I recommend subscribing to the channel so you're the first to see any and all new video content. Now onto our agenda. Yes, that's supposed to be a groundhog, not a chipmunk in the corner. But we're going to start today with a brief intro to cellular IoT with Blues. I know some of you are new to Blues, and I'd really like to make sure we're all kind of starting off on the same page. I'm also going to briefly show off some new hardware from SparkFun that was recently released that lets you take advantage of the DFU feature we're going to be talking about today. We're then going to look at a technical deep dive of Notecard Outboard Firmware Update, and as mentioned, see it all work in practice along with a cloud-based Datacake dashboard. And FYI, you're going to hear this feature we talk about today referred to as both Notecard Outboard Firmware Update and Outboard DFU. They are the same thing, so don't worry. So let's do some quick intros, starting with myself. My name is Rob Lauer. I'm Director of DevRel here at Blues Wireless. Far more importantly, with me today is Zach Fields. Zach is our staff DevX engineer, and he'll be presenting the technical deep dive I mentioned. TJ Van Tol is a principal developer advocate here at Blues, and along with Simon Kemper from Datacake, they're going to show off Outboard DFU in practice, along with some new Datacake features. So really quick Blues introduction. Let me start by stating that the mission of Blues Wireless is to make wireless IoT easier for developers and more affordable for all. So how do we make that happen? Well, our focus is really on securing your data from the moment it's acquired by a sensor all the way through to landing on your cloud app of choice, which today is Datacake. All the hardware solutions we provide are low power by default to the tune of about 8 microamps when idle, providing ridiculously good battery life. We are also a developer-focused company. Our developer experience is absolutely a top priority of ours. Hence, what I think you'll see is a really elegant and easy to use JSON-based API, and that's going to play out with the DFU demos today. So this is the Notecard. It is a cellular IoT device. It does come prepaid with 500 megabytes of data, 10 years of global cellular service. It's all baked into the cost of the device. There's no subscription fees. You're not paying month to month. There's no data caps, any of that. But Notecard is only half the story. The other half is our cloud service that we call NoteHub. Now, the two work together to form what we call a device-to-cloud data pump. So in practice, what this means is a developer is going to buy a dev kit. They're going to hook up one or more sensors to it. They're going to start reading data with the host microcontroller and then deliver that securely over cellular to NoteHub. So to be super clear, we are a cloud service, right? But we are not a platform. We really exist to help customers connect to their platform, be it a big cloud like AWS or Azure or an IoT platform like Datacake. So we're trying to solve that kind of messy, middle piece of connectivity so that customers can really easily and securely connect their devices to their cloud applications. Our groundhog showing up again. Zach, you gonna take care of this little farm it for us.
Yeah.
Zooming in on the Notecard just a little bit more. The Notecard is the core of what we provide. It is a low power system on module, measures a tiny 30 by 35 millimeters. It does have that M.2 edge connector at the bottom for embedding in your project. There are both cellular and Wi-Fi variants of the Notecard. As mentioned, the cellular variant comes with 500 megs of data and 10 years of global service. You can top them up with more data. The API is all JSON-based. There's no AT commands for managing your cellular modem, SDKs for popular languages, and Notecard varieties that work globally with a variety of protocols. So again, in terms of completing that device to cloud story, there's NoteHub. So again, NoteHub is that Blues Wireless cloud service that receives data as a proxy from the Notecard and securely routes it to your cloud app of choice. Within NoteHub, you can manage fleets of devices. As you can see today, we will be updating host firmware, but you can also update Notecard firmware with NoteHub. And NoteHub is all about securely transmitting data both from the Notecard and to your cloud. Data is actually transferred off the public internet via private VPN tunnels and can optionally be encrypted. So there's no certificate management, no key rotation required. Cool thing about using the Notecard with NoteHub is it knows exactly where to go the moment it's powered on. Now, finally, back on the hardware side, to make it easier to use your Notecard, like when you're prototyping or even when you're ready to embed in a more permanent solution, we provide these carrier boards called note carriers. They are development boards that let you snap in a Notecard and connect it to really any solution you can dream up. The Note Carrier F, for example, includes a feather compatible socket. The A includes headers that let you hook it up to any microcontroller you want. The B is a small form factor note carrier. The Pi is a Pi hat for working with Raspberry Pi and other single board computers like that. And finally, a new board from SparkFun was just released, as mentioned earlier. And this is their MicroMod cellular function board that TJ was holding up. I think it fits in with their MicroMod ecosystem. So we've been working with SparkFun for some time now to bring this board to market, and we are super, super excited about it. If you're not familiar with MicroMod, it's a modular ecosystem that connects a processor board with a variety of carrier boards. So it's super easy to prototype and swap interrupt processors and function boards on the fly. In fact, let me hold mine up here so you can see really closely. If you can see in the video here, I have one of the main boards here. With two function board slots here and here. This one has the new cellular function board. The other one's open. Then I have the STM32 processor board over here. So I highly recommend you check it out at this URL on sparkfun.com. The reason I mentioned this board explicitly today is because it is fully compatible with outboard DFU. Oh, that groundhog's still sticking around here. It's a horrible joke. I don't know why I stick with it.
You're committed to it, though. If you're going to do it, you got to
keep doing the joke over and over. It's perfect.
Yeah.
All right, let's start with the why of why we're even here today. So in my opinion, dare I say, those of us in the embedded space can be a little bit jealous of the typical cloud or software developer, right? They have this seamless development life cycle nailed down that includes, CI/CD, continuous integration, continuous deployment. But we're kind of stuck in this waterfall land of massively long release cycles that can easily take more than a year. Then even after deployment, right, we couldn't be further from that CI/CD nirvana, and instead are kind of presented with massive roadblocks when we want to improve, including the obvious risk of bricking fleets of devices in the field when doing something as trivial maybe as trying to fix a little bug. So in my mind, we're stuck with this difficult and really risky troubleshooting and fixing process, really leading to slow progress and frankly, very little innovation. So enter the Notecard and Outboard Firmware Update. So the Notecard can now use capabilities of modern MCUs to perform firmware updates, as we say, from the outside and not involving firmware running on the host. So think of it like an outboard motor here. Now, as we're going to see today, the Notecard controls the deployment of the firmware. That's super important to understand. So it can update firmware regardless of RTOS or language being used. It can even be used to switch between them if you want. So dare I say, this really provides the opportunity for more cloud-like agility in the embedded development cycle. So it really represents a new way of performing remote over-the-air device firmware updates, of course. It is an industry-first capability performed in a low-code manner that you'll see. Again, it does work independently of your RTOS or programming language. As mentioned, since the Notecard is controlling the DFU process, you can recover brick devices in the field. You can perform partial program updates. And maybe most importantly, it works on all modern ESP32 and STM32 based microcontrollers, with the caveat that the board you use has to expose the appropriate pins, which I'm sure Zach is going to touch on. So again, to differentiate from legacy OTA DFU capabilities, the outboard term is again like an outboard motor on a boat. It exists outside the boat, right? So it's the note card that's controlling the DFU process, not the host, which removes a ton of risk and can really increase your team's velocity. But that is really just my 1,000 mile up view of outboard firmware update. What we need to look at now are some of the technical details behind the feature. So for that, I'm going to pass the mic over to Zach to talk about the technical details, and then on to TJ and Simon for a demo. So I am going to stop sharing, Zach. You can take over.
All right, right on. So let's see. Let me get the magic of sharing happening on my computer here. So I think I'll give you guys this screen, and all right. So you guys can see. Yep, I see what you see now. So let me get this into that mode. Okay, so
Looks good.
my face isn't on here. That drives me nuts. Anyway, so can you? Right. So the deep dive on Notecard Outboard Firmware Update. So I'm going to try to go as deep as possible without boring you to death or taking way too long. So please make comments, anything, ask questions, and I will get around to all of them that I can. I'm not trying to leave polls. I'm just trying to not bore everyone to death. So let's get going. There's a couple ways to program microcontrollers, and one is a ISP or an in-system programmer, also known as the in-circuit serial programmer, or ICSP. It's more old-fashioned, or an in-application programmer. These are kind of the two main options that I'm aware of anyway. And the first one, ISP, is what you typically are used to when you've got an ST-Link, or even if you're just using your laptop to push firmware down to the device. Let's see, the other one being the IAP is whenever the host MCU handles it completely by itself, meaning that the firmware on the host must be completely aware of where your firmware is coming from, where to put it when it gets on the device, and how to switch over to it. So it's a lot more complex firmware, as well as you have to have twice as much program memory because you're going to have to be able to flash your program in there 2 times. So there's the 2 different models. And so the first one we'll get to is the in-system programmer. Like I said, it requires an external device, and that device knows how to talk to the MCU in a special way so that it can flash the entire program space. That typically will require strapping pins, which is like a boot pin and a reset, or in some cases with old microchip MCUs, they have a special voltage or pattern of bits to alert the MCU that a program's coming. The other one, again, we just talked about this, was the in-application programmer, which firmware A will understand how to receive and write firmware B, and then it'll go back, tell the bootloader, instead of jumping to me, I want you to jump to B, and then it'll be running B, and then whenever it's time to switch again, then B will rewrite A, and then tell the bootloader it's time to jump into A. So if we take a side-by-side comparison, the ISP does take external hardware, whereas the in-application programmer does not. But you're already going to be using a note card for your communication, so you kind of get the hardware for free because we're going to do that. And then after that, everything falls to the positive on the in-system programmer, and that is firmware can use the entire program memory space. Whereas on the other one, it's constrained to half of the program memory because it has to be able to hold it, and it has to be able to run and then rewrite the entire program all over again inside your program memory. Next, the firmware doesn't need to consider updates, which greatly simplifies the firmware. If you had, and this is super contrived, but a blink sketch, all it has to do is blink the LEDs. It doesn't need to handle firmware handling, which is an enormous and complex problem. Whereas on the in-application programmer, again, the firmware has to know how to do everything. So even if you have a simple app or a relatively simple app, it will become complex because it needs to do all of the negotiation to handle the switching of the firmware. And then finally, Rob said it, and it's true, with the IAP or the in-application programmer, you can get yourself into an unfixable state. If you write down something wrong, then your new firmware can no longer handle updates and you're effectively field bricked, or a technician would need to go all the way out to update, or climb on a ceiling or climb on the top of a building to update a firmware. Whereas with the in-system programmer or the Notecard's outboard DFU, what you're going to be able to do is the Notecard is what holds the firmware. The Notecard is what writes the firmware. So no matter what kind of a state you get the MCU in, you're able to pave it completely and then relay down new firmware. And so those are that's the main difference between your two choices. And we're providing the ISP side. So the Notecard, since you've already got the external hardware anyway, there is no drawback to it and only enormous advantages. Okay, so enough of that. That's what it is, but how does it work? Well, there's 5 real steps to getting this to take place, and they're pretty simple. So first, you need to establish a connection between the Notecard and the host MCU, an ISP connection. So you're going to wire the Notecard's auxiliary pins to the MCU's strapping pins, and you need some TX-RX lines so you can send the firmware across. Next step, you'll configure the Notecard for DFU. Let it know that it's going to be participating in this. The third step is you will use our tool called bin pack, and you will bin pack your binary files so that the Notecard knows where to put them in memory. And that's a little bit complicated, but I'm going to touch on it more deeply in the remaining slides. And then finally, once you've made this bin pack, which is kind of a organized binary file, if you want to think of it that way, you'll take that, you can put it up on NoteHub. And then the last step is to target. You don't have to deploy it to everything. You can deploy it to more than one at a time. You'll target the Notecards that you wish to send this firmware out to. So you could do a fleet, or you could just do arbitrary Notecards, your choice. And then you tell it to update, and then they will go down to the next time the Notecard checks in, it will receive the update that there is a firmware update outstanding, and then it will do the rest of the work. So that's kind of at a high level view how that's going to work. Okay, so let's talk about establishing the connection between the Notecard and the host MCU. It's pretty straightforward. So what we see here is I've got a little table that shows you we have these 4 auxiliary pins. It only requires 2, which is the one that connects to the boot pin. So both ESP32 and STM32 have this notion of a boot pin, where you're telling the bootloader, I'm going to send you new firmware. And when it's held during a reset, then that's its signal to be prepared for firmware. And then you'll use the TX and RX lines, or auxiliary TX and RX lines, to connect to the TX and RX, or the programming serial port of the host MCU. And so really it's those 4 connections plus ground, so that everything can know how to talk. But that's what it takes to get going. I use the Note Carrier B in the big illustration just so you can see how simple it is. It's really just 5 wires, and so we can support it with anything. And then the cool thing that Rob and TJ just showed you is we have this awesome new Spark board, which I'm super jealous because I don't have one, and you'll notice that both of them have one because they're misers and they don't share them, and they're rubbing them in my face. But we also have the Note Carrier F, which was our first board to implement this, and it works with our Swan, or really right now I would say our Swan. There have been people who have made it work with other Feather compatible boards, but you have to do a little bit of it doesn't just clip in and work, but it can work. But anyway, so that's the package where all the wires are done inside the PCB. You'll see it's the little one right underneath the words there. And then the big one that you see just above the table is a Note Carrier B, just directly wired to a Swan, so you can see what it does take. It takes very little, and you can do it with almost anything. All right, and so then next, what does it take to configure the note card for DFU to let it know that it's in this mode? It's extraordinarily simple. In fact, it's so simple. I did it for both the STM32 and the ESP32. You just say request card DFU name, and you tell it the architecture of the microcontroller that it's going to be supporting, so that it can use that as a check against what's inside of a bin pack. It lets it know that this is safe to flash. All right, so then bin packing binary files. Now this one it's actually simple to understand, but the ramifications are pretty big. So I'm going to go across this, and I'm going to give an example at the very end of what it exactly means when you're bin packing and how everything slots in. But right here, let's just take kind of a gloss over look. First off, you create a binary like you always create a binary, whether that's the Arduino IDE, ESP IDF, STM32 Cube IDE, or CMake. It's just do it the way you do it and get your binary file out and know where that's at. And then the second thing you need is our Notecard CLI. And that is a public repo, and you can go download that from GitHub. The URL is right here. It's under Blues Note-CLI. And inside of our Notecard CLI, we offer the bin pack utility. So bin pack will wrap up your binaries and tell the note card where you wish to target these binaries on the host microcontroller. So I gave two examples below. The first one is very straightforward, and then the second one is slightly more complicated, but you can see that it's really not. The first thing we see is that we say note card bin pack, okay, and then STM32, so you're just identifying the architecture you're wishing to target. You tell it the memory address and the binary that belongs at that memory address. So in the most simple case, it looks like the top one that's a slightly larger font. It may be hard to read. I can tell you how it goes later. And we'll make the slides available, I'm sure. So that's it. And then it will pack it up, create kind of a new looking binary file that you'll just upload to NoteHub. And there's no more to it than that. If you had a more complicated one where it likes to insert binaries at multiple binaries at different locations, we've got you covered on that too. You just keep repeating the last section there that is the targeted memory, a colon, and the binary that belongs at that target. So it just keeps going one after another, as many as you'd like to do. So it's pretty simple. Okay, and so now how do we upload it? We've made that easy as well. So if you go to your NoteHub account in your project, you get inside, there's a firmware tab down at the bottom. I've highlighted it here in red. And then you just choose the file from your hard drive, upload it, you're done. It takes no time because these binaries are super small. So the upload happens like a snap. And then once you have it up there, then you can go into your fleets. I've chosen fleet 3 here as an example, if you can kind of see the grayed out area. I selected 3 of my 4 note cards that I would like to see updated. And then whenever I click the update button, and it's on the far right, it has a little blue box around it, then it will list every firmware that I have put up on my project, and then I can choose from any of them and deploy them. It's incredibly simple. So that's actually it. That's actually kind of everything you need to know about how it works on the bin, on preparing and uploading, and then how you would finally download a firmware. So now I'm going to give you a more concrete example, and we'll just look at CircuitPython. This is kind of our go-to because it does a really nice job of illustrating how bin pack works, how targeted deployment works, and let's just get to it. So if you were to imagine that this picture you see before you is sectors or blocks of memory inside of your host MCU, you'll have different items at different places throughout the entire memory. So in CircuitPython, there's a couple ways you can do it. The most popular version is what you're seeing here. You'll have a UF2 bootloader sitting at this is on an STM, by the way. That's why it starts at 8000000. But that UTF bootloader is the first thing it boots into, which allows you to drag and drop files from your laptops, drag and drop a file from your laptop over USB onto the device. That's what the UF2 bootloader does. And then once that's done doing what it does, it jumps over to the CircuitPython interpreter. And then that sits back at 8010000. And then it will read all the way to 81 and a whole bunch of zeros looking for your Python script. So this is a neat way to look at memory and a good reason to show you why one of the utility of Notecard DFU is that you don't have to update the entire memory of the host microcontroller. You can simply update a single block at a time, and that just be it. So in this instance, what I'm showing you is, imagine you updated your script, you already have the UF2 bootloader and CircuitPython and a whole bunch of other junk on your microcontroller at this time. Well, now I'm going to take this script. You have to do a little bit of, we have a utility we've also created to turn scripts into binaries. So that's put an asterisk by that. But then you'll just take that super, super tiny binary, which is just a Python script, and slot it into place where the Python interpreter is expecting it. And then it'll reboot the microcontroller, and then the whole thing's running new MicroPython or CircuitPython firmware. Okay, so then what else could be done? Here's a natural progression of, if you can imagine a natural progression of DFUing a device. So what you're gonna have is the first thing we see up in the top left corner is the part I just described to you about just standard CircuitPython working. Well, you don't have to just update your CircuitPython. You could go in and blow away the UF2 bootloader and put an Arduino script. Let's say you were done with CircuitPython. There's something you need specifically from Arduino or the STM Cube IDE or anything, and you can generate that binary and just blow away the UF2 bootloader. And then what it becomes is it will just run that, and it leaves the rest of it sitting in memory, but it can no longer access it, or it no longer attempts to access it. And so it just looks like it's an Arduino application or whatever your application is running, and it's no longer behaving or executing the CircuitPython script. So there's an enormous amount of flexibility you can have. You only need to write what you want to write. You don't have to blow away the entire memory. This saves you data. This saves you time over the air, and it makes everything, and battery life. So it seems to be limitless awesomeness that comes from Notecard Outboard Firmware Update. And we are super excited for you guys to try it out. So now that I've talked too much, I'm going to turn this back over to TJ and let him give you an example of how that works exactly.
Yeah, good stuff. And I'm basically going to be showing off the same thing, but in action. And in fact, if I bring up my screen, you'll see that I've got this same checklist of 5 things. This was also on Zach's slides. And I'll also point out, and Rob shared the link in the chat so you can grab it from there. But if you go to our docs and you just search for firmware update in this box, you'll find this guide. This same list of 5 steps is here. So if you want to get back to this when you're ready to actually try this out, this is the place to go and check this out. But you'll see the first step, ensuring that your hardware is using the required wiring. So for this demo, I've got a No Carrier F. So this is basically everything I have here can be found in one of our starter kits. I've got a No Carrier F, got a Swan microcontroller plugged into it, and then I've got a note card. I've also got a BME 280 temperature and humidity sensor. And basically what I'm going to do for this demo is I've got a few of these you'll see lying around my office. So I'm going to spread these out throughout my house. We'll get some temperature readings from all over the place to simulate a small little sort of fleet of devices. And then I'm going to do an update on one of them without actually connecting it up, so you can just get a sense of how that process works. But in my case, for step one, for ensuring we have the required wiring, you'll see that a couple boards, the SparkFun, the fancy red board that Rob and I have, and Zach very much doesn't, is one of the supported boards, and also the Note Carrier F. And the cool thing about these boards is that the wiring is actually available just out of the box. So I don't even have to, Zach's diagram had only 5 wires. Well, I have only 0, which is even better because it's going to make my life really, really simple for getting started with Outboard Firmware Update. So, and in fact, because I'm doing that, I can just check this one off the list because I'm totally done. So step 2 is making sure that we have enabled Outboard Firmware Update on the note card. So to do that, if you recall from Zach's slide, it is a request that you send the note card, and the request is card.dfu. Now I want to put this sort of code that I have here in a little bit of context. So the firmware I'm going to be running is a pretty simple sketch here, an Arduino sketch. If you're not familiar with the Arduino environment too much, you don't have to understand all the details to get how this works. Essentially, all I'm going to be doing is taking a temperature reading in this loop function and using the note card's note.add request to actually send that up to NoteHub. And I'm going to be doing that every 30 seconds. So just taking temperature readings every 30 seconds, a pretty simple sketch. But for the part of Outboard Firmware Update, what I need to do is actually enable the feature so that the note card knows that I'm going to have the ability to update this host firmware. And to do that, I need to call the card.dfu request, which in Arduino, so our Note Arduino SDK, you do with this sort of syntax. The important things is I need to set on to true. That's the bit that actually enables it. And then I need to also include the name attribute and tell the note card what kind of architecture that I'm going to be using. I'm using the Swan, which has an STM32 based chip. So I'm going to include that. The other request in here that might be new to you, I've got this DFU status request. This is just going to provide some metadata about my firmware. So you'll see that over in here, I've got a version number. I'm going to call this initial version 0.1. And then this gets exposed. Really, all I just need to do is pass a string in here to provide a firmware version. And you'll see where this pops up in NoteHub. So I need to enable it by running this card.dfu. I do that. I can do that in my firmware itself, or I could do that. I could connect my note card through our web browser, our note card playground. I could do it there. I could do it with the note card CLI, but one way or another, I have to run card.dfu to enable the actual firmware update file. So at this point, I basically am ready to go with the initial version of my firmware, and I preloaded it on all of my devices to save us a little bit of time. So what I'm going to do is, before I get to actually updating the firmware, I'm going to go move these devices to some different places around my house. And you'll see, I'll just show in NoteHub real quick, because I have these up in here reporting values. And because I put in this DFU status of 0.1, you'll see that in NoteHub, if I go to the host firmware tab, they're all running 0.1 right now. And we're going to update that in a minute. But so that we can see these values, see, I'm reporting up temperature right now. So we can see these values in a little bit more elegant view than this table. I'm going to pass things over to Simon, who's going to walk you through showing these values in Datacake. And while he's doing that, I'm going to go on a trip to put these up in my house. And then when you see me come back, we're going to update some firmware and get some additional values on here and do some cool stuff with that. So Simon, you want to take it from here and get these values out? And then I'm going to go on mute and move some of these devices around.
Yeah, let's do it. So first of all, I'm going to prepare and I'm going to share my screen with you. 1 second. Hope this works now. And just let me drag this here away. So yeah, first of all, I want to introduce myself. So Simon Kemper, I am the founder and CEO of Datacake. Datacake is a IoT platform And we are offering interfaces for a couple of different device types. So for example, LoRaWAN, API device types, NB-IoT device types, and so on. And today, everything is about the Blues Wireless Notecard. And as Rob said, the Node Hub or the whole Blues ecosystem is a cloud service and a connected hardware. And it allows us to easily connect existing hardware, new hardware models using cellular, make it super easy to use cellular, and then connect it to any kind of cloud service. And today we are going to connect the project which TJ was setting up to Datacake, and he was inviting me into his weather station project, and this is what we already saw on TJ's desktop. So first of all, let's go back to the Datacake webpage. If you are on the webpage, you find this dashboard button in here. You can click on that. And this brings us to the login for Datacake. Datacake is a web-based solution, a cloud-based solution, and you can register for free. And I've already created a demo account for this webinar here, and I'm going to log in right now. So this brings you to your first workspace. And I'm just going to drag the Zoom controls a little bit away from here. This brings you to the first workspace, and a workspace is the space where you can add devices, members, create reports and rules, and so on. So to add TJ's note cards, we are going to press on the blue Add Device button on top, and we are going to select API, which is a generic integration for any kind of MQTT and HTTP devices. We press on Next. And this allows us now to define a product. A product is like a definition for 1 or 100 or thousands of devices, and the things you enter in the product, all the devices belonging to that product inherit automatically, have the same dashboard configuration, and so on. To make it super easy, we already have a couple of templates available, and we also got a template for the Blues Wireless Notecard. So if you are adding a new device, make sure you select API, product, and then template, and select the Blues Wireless Notecard template. Scroll down, press on Next, and this will now ask us for serial numbers. And we can define how we do the matching from incoming data to devices on Datacake. But in this case, we are using the Blues Wireless serial numbers. So let's go back to the weather station. And in here, we've got TJ's devices, 3 of them. And I'm going to open up, I think I need to click on View here. The first one, copy the serial number back to Datacake. That was the wrong one. Back to Datacake. Paste the first one in here. The name will be the same. Then there's 3 devices. Let's go to the next one and copy the serial number as well. Back to Datacake, pasting this here. And last but not least, the third one. I'm not sure if there's a quicker hotkey or something like that to copy the serial numbers, but I'm doing it in that way. Paste it in here, and also the name will be the serial number. Next, you can pick a plan. We support different kinds of pricing plans, 2 devices for free. Right now we are at 3 devices, so we need either a paid plan or a code. And I created a code for this webinar, which is Blues Wireless or Blues Webinar, I hope. 2023, let's check. Yes, it's Blues Webinar 2023. We will share this code later on. You can use it as well. And we support up to 10 free devices additionally for you if you want to try out the Datacake platform. So let's add these 3 devices. They will be now added to the workspace. You can see them in here. And we can also switch on the product here. And as we can see, this is all belonging to the same product. So what we now need to do is we've created the devices on Datacake, and they're already living on the Blues Node Hub. So we need to connect the Node Hub to Datacake. And this is done by using a unique URL. And let's go into, just to show you how, click on one device, go into the configuration, and then we scroll down a little bit until we reach to the HTTP payload decoder. More on that in a few. And then we've got an endpoint URL. And this is especially created for that kind of product. And we simply copy this here, and then we go into the Blues Node Hub. And as Rob mentioned in the beginning, that the Node Hub makes it easy to connect cloud services. They have these routes in here, and these routes route data from the Node Hub to attached cloud services. So we are going to create a new route, and we simply select the first one, HTTPS. And all we need to do here is we need to give it a name, Datacake route. Sorry for that. And the URL is simply pasting the URL I copied from Datacake. We can leave everything like it is, no special adjustments needed. You can if you want, but not needed yet. Not needed now. Let's create the route. The route is now created. And I'm not sure, TJ, you said they are sending every 30 seconds. So that means there's at least one device sending data already?
Should be, yep.
Yeah, okay, that's cool. Now we've connected it to Datacake. So let's go back into our workspace on Datacake. I'm just going to click here on the devices sidebar and reload the page once more. So maybe we can already see some data flowing in. I think there's also like a log in here, which says 200, which is successful. That means that data is flowing into Datacake. And of course, it's now not showing my devices because it's a live webinar. That was so clear that it happens. Just 1 second. I got a notification. Maybe.
Yeah, the first of the data did just go through. So
yes, the data goes through. Let's see. There's like, yeah, something was happening. It's always, these things always happened. Maybe the team I was telling them not to deploy any new feature within the next 2 hours. So, but this looks like a deploy because it was also kicking me out. Okay, let's wait. Let's see what happens in here. But it looks like it's forwarding the data, or maybe I don't know what's going on. Okay, now it worked. It's back there. So it was probably a deploy. Somebody was hitting the deploy button. I also got a Slack message, so maybe somebody was apologizing for it. So as we can see here, data is already flowing in. So that was all we need to do to connect the Node Hub to Datacake. And now if I go to one of those devices and click on one of those, we can see that there's data already. This is actually a standard template. In this template, we are also accessing a couple of different data. And this depends on what you activate on the Node Hub. So it's also forwarding, if you activate this, the RSSI voltage and things like that. But in this case, we're just forwarding the temperature. And we can also see here under configuration in the logs that we can see here these events coming from the Node Hub with all these additional informations in here. Just to show you how the whole payload decoding works. I've mentioned before that we support any kind of HTTP requests. And in this template, there is a payload decoder, which decodes the information coming from the Node Hub. And in here, these two little lines for temperature and humidity actually convert the information coming from TJ's Node cards to Datacake, and they are decoded in here. And we got these additional informations in here. And there's also a tower location, which is pretty cool because the Node Hub also sends us a GPS information based on, in this case, the cellular towers. So it's using cellular triangulation, I guess. Let's go once more into the dashboard. We can see this is, I think, TJ, this is close to your location, probably.
Yep.
And this is showing us the cell tower. Because we attached it to the cell tower location. And if I go to devices, I can also switch on grid. I can see, okay, this device is sending us some data. And I'm going to switch to map to see these devices here on the map as well. So this is how you hook up the devices to Datacake. And before I continue to add all of these three devices to one floor plan dashboard, which I wanted to show you, I've seen that one of these devices is offline, and this means that probably, TJ, you want to update some firmware on it, or maybe, show the outboard DFO firmware tool, right?
Yeah, I can take a minute to update, and then we can head back to the dashboard to see what it looks like. Sound like a plan?
Okay, I'm stopping and handing over to you.
Perfect. Yeah, so I'll take over and we'll return to our steps. So I've got 3 different devices situated in different areas. of my house. And what I want to do is now I'm basically simulating a semi-real-ish world IoT deployment where I've got devices out in the field in different areas. And then I need to perform an update to it, right? Maybe I discovered a bug, or maybe I have a new feature that I want to add. And I don't want to physically go visit all my devices and plug them in and flash the new firmware. I want to do it all from the comfort of my desk right here. So if we return back to our checklist, you'll see that step 3 is to build your firmware image file. So what I did while Simon was showing off the dashboard is I made an updated version of the firmware. And so I bumped this guy up, this version number to 0.2. And the only things I added, if I scroll down here, I'm additionally taking a humidity reading from the BME 280 that I've got connected to my devices. And then I'm also sending the humidity along with the temperature in the body of these notes every 30 seconds up to NoteHub. So in this case, this is where I would normally plug in through USB, take this firmware, flash it to my devices. But in this case, I'm going to build the binary file. Now, Zach mentioned in his slides, this is sort of specific to the platform that you're using. In Arduino IDE, there is an option in the sketch menu for exporting the compiled binary. The menu is, of course, in my other monitor, so you're not seeing it. But when I click it, it's going to compile the sketch, and it's going to generate a binary or a .bin file. So it's compiling real quick. And then when it's done, it'll spit out the path it's at in my file system, which is over here. This is a weather station. Arduino IDE at least creates this build folder with the different files you need. So in my case, I need this weather station.bin file. So I am going to place this on my desktop. I'll drag it over here so you can see it. And then the extra part of building, as Zach mentioned earlier, is the bin packing. So in my case, I've got this ready to go. I've got the Notecard CLI installed. I'm going to pass the bin pack option. This is an STM32 based chip that I'm building this firmware for. And then I just need a path to my file. This takes like a second, and it compresses the binary a little bit too, which is nice. And what it generates is this one over here, this .bin pack file, which is the actual firmware that I'm going to upload to NoteHub. And so we have built it. It's ready to go. That was that step. And so now we need to actually upload the firmware on NoteHub. So I'm going to drag my NoteHub project back over here. And I'm going to go to this firmware tab on the bottom left hand of the menu. And I still have one of them from when I was practicing here. So I'm just going to clear a slate so it's a fresh version of what you'll see on this screen. And I'm going to upload my firmware. And I'm just going to select this bin pack file that I just created, open this up, and add some notes. We added humidity support in this version of the firmware. I'm going to save it. The firmware is kind of small, so you see that update might as well have been instantaneous. To upload this to NoteHub. And from there, all we need to do is apply the firmware updates to our devices. So in my case, to keep things simple, I'm just going to apply it to this one device that's in my office. And if I go to the host firmware tab, I can see the current version's running. And I'm going to say for my office one, I want to update it. So you see it's pretty easy, just sort of point and click. I've got my firmware version where I added humidity support. If I had multiple bin packs up here, I could use all of them. I could apply it. And really, that's the entire process. And in fact, if I go back to my checklist, we uploaded our firmware. So that is done. And you'll see the last step is actually kind of a passive step, right? Because we were doing all these other steps. At this point, the note card is now in control. So the note card is going to send down to, the note hub is going to send down to the note card that there is a firmware update that is available that will happen on the next sync. So if I go into my device, I'll show you where you can monitor the progress of this. So if you go into the device and then you go into this host firmware tab and you scroll down, you'll see this firmware update request section. So as a start, it'll always say pending device sync, because depending on how you've configured the note card, essentially the next time the note card performs a sync of NoteHub, it'll check if there are any firmware updates that need to occur. Now, if I go back to my sketch, you'll see that I configured this note card to be in continuous mode, to sync all the times for demo purposes, because I wanted it for demo purposes. I want this firmware update to happen as fast as possible. But if you're in periodic mode, if you have an outboard interval configured or an inboard interval configured, the firmware update will happen the next time the device sync happens. And since I have it going down, happening pretty fast, you'll see that it's already picked up on it. The note card is currently handling the request. It'll download it. This download is going to happen kind of fast because this binary is kind of small. You can also keep track of the progress in the events tab. You'll see that I got this note here too that said the download started. If I keep refreshing in here, you'll see that it's going to continue to work. And what's kind of cool is that the device is handling this kind of completely on its own. The firmware is going to continue to execute sort of as expected. It all happens fairly seamlessly. And we'll know it's done both when I see the updated DFU status, so we see version 0.2. But what I'm really looking for is for a humidity to start showing up in my notes, because that's the main feature that I am adding. And at this point, it's just sort of a wait and see game, because we know the fact that the note card is offline. This means this should be just about done. It's handling the request. This point, Rob, I don't know if there's any questions we want to handle while we're waiting for this guy to finish up.
Yeah, for sure. Actually, Zach, I'm going to put you on the spot because there was a lot of technical questions that were asked. Is there any that stood out to you off the top of your head?
Let's see. Yeah. Yes, there were actually a ton of amazing technical questions. I answered as many as I could, and I promptly forgot all of them. So let me, really, honest to goodness, they really were awesome. Let me scroll through it as fast as possible. There were a couple that definitely should have been answered to everybody. Let's see, is it? Let's talk about. Okay, how about this? This is a good one that I didn't get to. Would it be possible to get a deep dive or demonstration using the Blues bin pack, basically for Circuit Python? I'd say that's probably outside of the scope of today's talk. I know we touch on it throughout our documentation on dev.blues.io. And if you'll reach out on our forum, like discuss.blues, right? .io. Okay. Yeah, we definitely will. That would be a great place, because that's an awesome thing, and it would be great for the community, I think, as well. So that would be the appropriate place to have that conversation. But we do cover a lot of it. But any holes that we have in the documentation, it'd be great to bring them into the forum, so then we can improve the documentation, as well as have a thread for everyone who wants to know how to do this. But it really is pretty simple. So I'll just talk to it while that's getting worked out. The idea is you would, in the way that I was showing you bin pack something, you tell it your target architecture. So it's note card is the name of the CLI, then hyphen bin pack, name of the architecture. So ESP32, STM32, whatever. And then after that, you start specifying memory locations. So I'll talk about STM32 because I'm most familiar with it. But at the regular launching place of all STM stuff is 8 followed by 6 zeros. And so that is where you want to begin. And so that's where you'll put either the UF2 bootloader or the Python interpreter if you don't want the bootloader. And so you can target that with a bin pack. And then the script start at 8, 1 followed by 6 zeros, and there are 5 zeros. And then that's where you'll target the script. And so by putting those in place, that's one giant bin pack when you target that much. And it's really not that much. It's just the interpreter is giant. So it'll write that section. It skips everything all the way up till 8100 and writes that one. And so, yeah, and then there forever after, then you just target the 81000000, and then that's just a tiny script that lays down every time after that. But like I said, all great stuff for the forum. Love to talk about it there. And but it just keeps going and going, like the way I keep not stopping talking. So I'll let them take back over now.
TJ, any luck?
Yeah, I clicked the wrong device, so it's starting back up when I did it. So
Simon, do you want to show off the Datacake side? I know we're not going to have the fresh data. Exactly.
Yes,
right.
sure, of course. Once more, 1 second, please. And should be the right screen. It's always in Zoom. There's like hundreds of different options, but I think looks good. So we are back in Datacake. We can now see that we have 3 devices online here, but I think that the temperature is still missing, so the firmware update is still going on. And while this is going on, let's go create a dashboard just to bring them on a cool floor plan. In Datacake, you have different kinds of dashboards. You have device dashboards, which is a dashboard that comes with a device. You have the option to, oh, by the way, we also see now voltage and RSSI. You have the option to define and change the layout of the dashboard, but also to make it public. If you want to share a dashboard of a device very quickly, you could scan it now and this will appear on your phone. As well, desktop and mobile is supported. But if you want to show all these 3 devices around TJ's house, we can build him a dashboard, which is just for his house, using a floor plan, for example. And this is one of our latest widgets, which supports uploading of images. It's the image map widget, and you can simply upload a file. And for example, I've tried to find some pretty cool floor plans on the internet. Let's take this one, for example. Upload this to this widget, press on save, and then we've got this here on our Datacake dashboard. And now under data, I can add devices and also the temperature and the position. We can change, this is the device which firmware is still updating. So let's put this into the bedroom, add next device and select the second one and the temperature, and put this, for example, in the living room, add device, third device, and select the temperature, put this device into the entrance, for example, or the outside. I'm not sure. I forgot to name which one is outside and inside, so I'm just placing them like they are right here. We can also change the size of it. We could also provide a unit, and under appearance, we could also change the way the colorization works. So for example, if it's above 20, it's warm, but if it's around 10, it's cold. We save this, and we can now see these devices here on our, I'm sorry, my mouse is a bit, the touch field is a bit working. There they are. And we can see these devices in here on the floor plan. Somehow not all devices of them, probably I made a mistake, I'm not sure. No, they are here. Let's see what happens. This is the device. This is also working, and this device is outside. Let's move it. Yeah, okay, there they are. The device that's still updating is having no temperature, so it's not appearing here, but you can see these devices here around this floor plan. And once you click on one of those devices, so imagine you have multiple around your house or your office floor, you can click on each one of those and can also see some more details in our sidebar here. And also, yeah, you can define the dashboard we see here on our sidebar. Let's go back into the devices. And maybe we can see that the device which we were updating, is bringing some new data. 1 second.
Yeah,
this one here.
One of my devices, the battery died, which is why when I tried to update the one with a dead battery, it didn't work. So one of them is not going to be recovered, but the other 2 are online. Turns out that firmware update cannot fix a dead battery, as it turns out.
Yeah, so, but that's fine. That's fine. Yeah. Okay, but for this, for example, Datacake could help you and set up a rule if you have this device, and then you can choose the battery, for example, like the voltage in here. I know that voltage does not reflect the state of charge, but you can derive it from there. And if this is less than, for example, 3 volts, send an email to TJ, to Rob, to somebody else to replace, or send an SMS, or even call a downlink, which is a command to device back. Yeah, and well, I mean, in this overview, we wanted to show how you can quickly connect the Node Hub to Datacake, which works pretty easy. And for the 2 devices, it's free. And if you use the code I just pasted in the Zoom chat, then you can add up to 10 devices for free on the free plan testing for it. So from my side, this is what I wanted to show on Datacake. I think we're also almost over with the webinar in terms of the time. So I'm stopping sharing my screen and handing over to you.
Great. Yeah, I'll just quick 30 seconds show the end result of when you choose the right device that has battery charge. But you'll see that basically the only parts that are new here is that when it does finish, you'll see an event that the host firmware update completed. And in our case, version 2 had that humidity support. So humidity is now in here. And if I go back to my devices, I go back to host firmware. The Office one shows, if I go to the host firmware tab, that the firmware update's completed. So like I said, you can't magically solve your battery issues, but it really is just a few clicks to get new firmware updates out, push them out to your device, manage everything through Node Hub, and yeah, pretty cool stuff.
Awesome. Yeah, and I can just confirm it, because on the Datacake dashboard, you can now see the humidity for that device as well being recorded.
Cool. So I lied to y'all. I thought for sure we'd be done in 1 hour. We're just going to go a couple minutes over. What I did want to do before really wrapping up, I wanted to know that next month on March 10th, we're hosting a TinyML plus IoT plus cloud bootcamp of sorts, along with our friends at Edge Impulse, and Simon will be back again from Datacake. We're hosting a hands-on but virtual workshop. So you can get all the details at this URL here at bit.ly/blues-tinyml. So it's going to be mostly hands-on, walking you through building your own machine learning-based application. Runs on a tiny microcontroller. Also ties into IoT in the cloud, of course. It's going to be great, I think. If you're at all curious about using ML on constrained devices, this is a great beginner/intermediate level starting point. So before we jump into a quick Q&A, I did want to share some resources that were shared during the presentation. So head to blues.dev for technical resources and how-tos on using this new feature. Again, check out sparkfun.com for their new note carrier on the Micromod ecosystem. And again, here's that URL for the TinyML bootcamp on March 10th. And you can try out Datacake again with the code that Simon posted, Blues Webinar 2023. With that, let's do just a couple minutes of any really good questions. Zach, were there any others that stood out? I know we tried to answer everything live, but privately, was there anything that's worth answering?
Well, I see one here that was a source of confusion. So one thing about Notecard Outboard DFU at this time is we are targeting STM32 and ESP32 predominantly. We have a proof of concept on an NRF 52840, and we are trying to get that merged back into the main, not our stuff, but the other stuff that supports that, and we're hosting it currently in case anyone wants to try to work with it. So we have a solution at this time. However, we're trying to get that merged back into the main. At this time, we are not supporting Atmel chips or other types of microcontrollers. So really, we need to have the way that this works, and what's a really important key factor I kind of glossed over is that it works really good when there is a ROM bootloader. So an immutable bootloader that the microcontroller has, so that it always jumps to a certain location, so that we can rewrite that location and put down your new firmware there. That isn't true of the NRF, so we've made accommodation for that chip. It has a bootloader in the program memory. We dance around that and then get into the right spot. But at this time, we're not doing Atmel. So someone had asked if, like, how do we get the output from Atmel Studio into BinPack? It'd be easy to do, right? You just find the file, you tell it to wrap it in this BinPack, which is basically a header that tells it where to find, and it brings everything together into one file and gives it effectively a table of where everything is and where everything should go. But it would be to no avail if you're trying to do Atmel at this time, because we don't support that path. So that's one.
Somebody just asked what Notecard firmware version is required, and I think it's 3.5.1.
I believe that's correct as well.
Yeah. And it's definitely in the docs and the guide too.
Somebody talked about using STM32 protections that prevent the debug port or limit the functionality. I don't know. Like, it depends a lot. You could set it up with that's the option bytes on the STM32, right? So we're not toggling option bytes in that way, or at least not at this time. And so that would be up to you to set on the device prior to, and then, but leave it open for firmware updates. So again, I don't know. I don't know enough about option bytes. There's a million of them and they can become complex. So I don't want to try to give you a fake answer there. But it would, as long as your option bytes don't interfere with the ODFU process, then you can set them to whatever you like and then still be able to ODFU. That would be the real answer there. And then I'm just trying to quickly look at any other ones.
Question for Simon I was going to ask quick. Somebody asked, can you apply the Datacake rules to multiple devices at a time, like a fleet in NoteHub? I think that's a great question.
Yes, right now you can add multiple devices into a single rule. That still is a bit manual. What we are actually right now working on is a rule that works on product level. That means you have one product with 300 devices, for example, and then you add just one rule. And also in that rule, you can get values from configuration fields on devices. So that means you just need one rule which controls 300 devices. This is the new feature coming next month. And right now in the rule that I was showing, you can add multiple devices, chain them via AND or OR, and yeah, turn them into a single action. So yes, you can.
Somebody also asked, I just saw this one, where do you enter the code for Datacake? I think that's when you're adding devices, is that right?
Yes, when you add devices, this is where you need to choose a payment plan. We support also custom package pricing once you scale to a certain amount of devices, and happy to talk about any custom quotation. But when you start self-service with Datacake, you need to choose a plan. 2 devices are for free, and if you want to have up to 10 free devices, there's a code field. You simply paste in the code, press on apply, and then the code gets applied.
Cool. Unless there's any other really critical ones, Zach, you wanted to answer.
Yeah,
if we didn't get to your question, please hit us up on the forum at discuss.blues.io, but I'll turn it over to Zach for one more.
Yeah, I'll try to go rapid fire. There's 2, but they're both important. So one says, our MCU application puts a Notecard and MCU to sleep and wakes up every hour. Does this impact whatever? The answer is sort of. One, the most important thing, and the reason I really want to answer this is we don't support putting the Notecard to sleep. That's why it runs at 8 microamps. It is to remain the way that it is designed is to be on all the time. You can cause corruption of the memory whenever you do that. What would happen, it's not really going to destroy anything if that happens. On the safety side of things, if you were to kill it in the middle of it trying to download, it's just going to see that it was no longer able to download as if it had lost connection to the internet. So we're resilient to that because of it could lose internet connection. However, that is not good, and we don't support using the Notecard in that way. So I just wanted to call that one out. And then the other one I saw down here was, do you have any guidance for using a bare STM32 and not the Swan? Yes, that's why I tried to show I showed the Swan there, but the point is that it's connected to the boot 0 pin. That's the main thing, and reset. And then you have to determine which serial port is capable of programming the microcontroller, and then ground. So if you have those 5 things, which you'll definitely have ground exposed, you have to have a boot 0 exposed, and then you have to have your reset pin, which everybody seems to also have, and then access to the programming serial port. And then honestly, we do believe that we support any single STM32. That's our goal. Any modern STM32, that's our goal. Yes, you certainly can. Boot 0, reset, TXRX, and ground.
Awesome. Groundhog says it's time to be done. All right. Thanks everyone for attending. Again, hit us up on discuss.blues.io with any other questions, but thanks to all of our speakers, and yeah, have a great rest of your day.
Thank you as well.